also Pearl. Okay, so for those who just came in, just now I asked how's your progress on the first part of this chapter 7. Okay, that is constructing the histogram and also the frequency polygon. If there's any question you want to ask about that, you may ask now before I proceed to the second part. Okay, is there any? If total silence means no question lah. Okay, I give you 5 seconds lah. Start from now. 5, 4, 3, 2, 1. Okay, so means no question. And I hope you master the skill lah, okay, of how to construct histogram and also frequency polygon. So I would like to share my screen first. Okay, I would like to show you my PowerPoint. Okay, if you can see the slide, can you please respond to me? Can you see the slide?
Can, sir.
Can?
Yes.
Okay, very good. Can you see it moving?
Yes.
Yes, okay, good. Okay, so this is a PowerPoint. So let's go through very fast about the first class lah. Okay, the first and second class where we already done all this. How to construct the frequency table, how to determine the cumulative frequency. This is the part is very important because when you want to construct the OGIF later, you need this cumulative frequency. Okay, so you need to know how to find the cumulative frequency. Okay, given you a table of data lah. So this is how we find the frequency, cumulative frequency. Can you see my drawing here? Can?
Yes, sir.
Okay, very good. All right, so this is the part. We will use this later when we construct the OGIF. And also this is the histogram. Okay, histogram. Okay, the height. This is just a definition. And this is the steps for constructing histogram. It's very easy. You just use the upper and lower boundary for the x-axis, and also the frequency for the y-axis. Okay, and this is the example of frequency polygon. And for frequency polygon, I want to highlight something, which is this one, okay, and this one. Meaning, okay, if the question didn't give you a class interval with the frequency 0, you need to find it yourself. Okay, you have to find it yourself for a class interval before the first class and also one class after the last class interval. Okay, and that the frequency is 0, so that you get these 2 points. If not, your frequency polygon will just hang in the air. Okay, if you don't have this this point, okay, your okay, sorry. Bangkok. Pardon my pen because my pen is so lousy. Okay, ignore this part also. Okay, if you don't find the class interval with the frequency 0, you will find out your after you construct your polygon. Okay, it will not touch the x-axis like here. Okay, it will not touch the x-axis. So that's why you need to find class before and one class after. Okay, with the frequency 0, so that you can plot your graph until in the x-axis. Okay, let's say for here it's like this lah. Okay, for example lah. Okay, this actually is wrong. Okay, so you will get these 2 points. So this is very important in frequency polygon. Okay. Okay, this is what frequency? Okay. Yeah, just like this. If you notice this table, the number of cars is actually your frequency lah. This is your frequency. Okay, so you notice there's no class given with the frequency 0. So what you do is you need to find out yourself one class above this one. What is the class interval for this one? And the frequency for this one should be 0. And also you need to find out one more class after this one. Okay, the class interval with the frequency 0. Okay, so that you can construct your frequency polygon in a complete manner. Okay, in a complete manner means you start from x-axis here. Okay, and it will end at the x-axis also. Okay, so this is very important. So how to find the interval, class interval before and after? And actually, you can see the pattern here also. Okay, you see this one, the upper boundary. Oh no, the upper limit is 79. Okay, 89, 99. So the previous, this one should be 69, right? This one should be 69. Okay, according to the pattern. And then for this one, 119, 129, this one should be 139. Okay, and then the front one, the lower limit, so you see 100, 110, 120, so this one should be 130 lah. Okay, 130. So you find out this class interval. And then for the previous one also do the same thing lah. This one it should be 60, and then this should be 69. Okay, and this frequency should be 0 lah. Okay, because the data don't have this class interval. Okay, in your data. So this one, the frequency should be 0. So after that, you all get all these numbers, then you can construct either a frequency polygon or a histogram. It's actually, you can draw the two graph in the same axis. Okay, just that the frequency polygon you use a midpoint, whereas the sorry, there's someone coming in. I need to allow first. Okay. Okay. Okay, so we continue. Just now I said that you can draw two graph in one. Okay, two in one. Okay, meaning the frequency polygon and histogram in one axis. Okay, y and x axis. The difference between that is just the midpoint. For frequency polygon, you need to use the midpoint. Okay, oh sorry. Okay, what you use is the midpoint here. Where is my pencil? Okay, this one, this point is actually the midpoint. Okay, the midpoint of in the x-axis. Okay, whereas this one is the frequency of this one is actually frequency. But when you want to draw, you don't write frequency lah. Okay, you don't write frequency, but you have to follow the title of the question. If the question said this is the number of cars, then you put number of cars. But actually, this one is referring to the frequency lah. Okay, referring to the frequency. So just the difference is that this is the upper and lower boundary. Okay, whereas the polygon, you use the midpoint. Okay, you use the midpoint as your x-axis. Okay, so you can do it in the same graph. Okay, so I think just go through this one very fast because you already done it. Okay, just want to highlight some of the points lah. Okay, that you need to take note. Okay, so this one is the thing that I want to cover today. Okay, is sometimes the question will ask you about the distribution. Okay, how the data distribute. Okay, so you can describe this data distribution in four types lah. Okay, in 4 types. One is the bell shape. Okay, bell shape. This is the bell shape. Okay, if you look at the shape, it's like the bell shape. Okay, just like in our school, we got a bell near the near the water filter there. Okay, if you notice near the office, there's a bell. So this one is the bell shape. Okay, whereas this one is a uniform shape. This is called uniform shape. Okay, although it's not really uniform lah. Okay, it's actually can consider as uniform because you can see some kind of straight line here. Okay, so this is called uniform. And then this one is a right skew, and this one is a left skew. Okay, excuse me, I think I need to allow someone in. Okay. All right. Okay, continue. Okay. So when the question asks you how the data distribute, okay, you can look at the histogram or the frequency polygon to see that given histogram is actually which shape. Okay, given this one given there are 4 types of shape here so you can refer to this notes it's in your textbook So this is a right skew. Right skew means is first of all it will go up and then it will gradually coming down, okay, to the right hand side. So it's a called right skew. And opposite to this one is a left skew okay, left skew. Okay, so this is 4 types of distribution, okay, data distribution. And let's look at one example question, okay. So the diagram below shows 2 histograms representing the time taken by 25 swimmers to complete 2 different events. Okay, one is backstroke and one is freestyle. So you look at the histogram, okay, you're given that the time taken for 100 meter. This is the backstroke, and this is the time taken for 25 students in 100 meter freestyle. So the question comes, A, state the distribution shape, okay, of the histogram for the 2 events. So if you notice these 2 graph, okay, or 2 histogram have different shape, right? So what is the shape for the first one? What do you think? Anyone can answer? Can give me an answer? What do you
Bell
think this should? Sorry?
Bell shape.
Bell shape. Okay. Who is answering? I'm sorry, I cannot see the Google Meet. Who is answering? Siwen. Okay, very good, Siwen. Okay, if you compare with the note just now, you see it's very similar to this one. So actually, this is the bell shape. Okay, very good. Good try. How about the second one? Anyone? What is this shape given? Okay. And it's very obvious, very obvious. This is, if you look at this this chart here, histogram here, you can notice it's actually this one, uniform shape. Okay, although it's something like up and down, but it's not too high or too low okay, it's about similar okay, so we can say this shape is actually a uniform shape. Okay, so that's the answer for question A. Okay, question B, which event has a wider dispersion of the time taken? Give your reason. Okay, so normally when you want to analyze your data or for a given graph like histogram or frequency polygon, you look at the dispersion. Okay, the question will ask you the dispersion. So for dispersion, normally we will take the lowest mark or lowest time for this question, or the fastest time, and then we will look at the longest time given, and we will try to find the difference. Okay, we will try to find the difference. Okay, and then compare the 2 events. Okay, the difference for the backstroke and the difference for the freestyle. Okay, if the difference is larger for let's say backstroke, then we can say that the dispersion in this event is larger compared to freestyle. Or if the opposite, if you find out that the difference between the highest or the longest time taken compared to the higher fastest time taken is larger in freestyle, we can say that, okay, the event, okay, for freestyle is larger. I mean, the dispersion is larger compared to backstroke. Okay, so if you look at here, actually it's very obvious that the event for backstroke has the larger dispersion or the wider dispersion, because you see at the fastest time, okay, both fastest time is the same, 69. But you look at the longest time, Okay, for this one is 104. Here is only 89. So it's very obvious that backstroke has the wider dispersion. Okay, when you want to give your reason, you can find the difference now, because the difference, or you can say the difference between the longest time and the fastest time is how many for this graph, and then compare to this freestyle. Okay, so you can compare the difference. So that is your answer. And okay, someone is coming also. Okay, all right. Okay, so we continue. Okay, so the question C. Between backstroke and freestyle, in which event did the swimmers perform better? Okay, so for you to conclude which students or which swimmers perform better in which event, because you have to understand that this is a swimming competition. So for swimming competition, of course, if you get a faster time, then you will consider better, right? So if you look at the histogram, both histogram, you can see that the swimmers in the freestyle events will perform better, all right? Because most of the students get a faster time compared to the swimmer in the backstroke event, okay? So you can conclude that the swimmer in the freestyle event is better, okay? So you can, this is very logical thinking, okay? Just look at the graph, look at the event, what kind of event is that? And then look at the histogram, look at the data. So you will find the answer, okay? So this just tests your observation. Okay, so this is the answer, okay? And we look at another one, okay? Look at another one, example. Okay, so given you two frequency polygon, okay, so show the selling prices of the houses that were sold in two different areas, okay, in the last 6 months, okay. Red color is area A, blue color is area B. Okay, state the distribution shapes in the two areas. Okay, so what kind of shape or what kind of distribution can you see? Let's start with area A lah, area A. So what kind of distribution, what shape is this? Anyone? The red color. Is it uniform? Is it a bell shape? Is it right skew, left skew? Which one? Anyone can try?
Right, sir.
Right
Right skew.
Right skew, okay. Right skew, let's look at the notes before that. Is it right skew? So the red color polygon is similar to this one, right? Okay, it first go up and then gradually it comes down. Okay, so this is right skew. Okay, very good. Okay, so if this one red color is right skew, of course this one, the blue color, should be left skew. Okay, if you look at the point plotted here, it will gradually comes up, okay, and then goes down. Okay, so this is a left skew. And then you can see the points is not uniform, so it's actually going up and then going down. So this is actually left skew. Okay, so that's the answer for A. Okay, B, compare the dispersion of the house prices in the two areas. So compare the dispersion. Again, this question asks you to compare the dispersion. So what you can do is actually you can find the lowest price and the highest price for area A, and then find the highest price here for area B and the lowest price for area B, and then find the difference. Okay, I already done here actually. Okay, I already done here. For red color, the highest price should be this one, 327,499.5. Okay, this is the first one, and then minus this one for the 400 47,499. which is this one, this point. So when I find the difference between the highest and the lowest price, I found out it's 280,000. And then for the blue one also, I found out it's 280,000. So what can you say about their dispersion? Of course, it's very obvious that the dispersion for these two areas are more or less the same, okay? More or less the same, the dispersion. But there's a difference in the shape, in the graph shape. Although the dispersion quite same, okay, similar, but then you can say that the graph or the shape of the graph is different, okay? So this is the answer. Okay, in your opinion, which area represent an urban and which area represent a rural area? So any answer from you? You can try. Area A is rural or urban? Or you can say area B is rural or urban. And don't forget, this is the price, the price of houses. So look at the price for area A. Okay, 47,000 here. Highest is 327,000. Whereas for area B, the lowest is around 117,000, 100,000, and the highest is almost 400,000. So you can say that area B got the higher selling price, right, compared to area A. So normally in a rural area or in urban area, which is got the higher selling price?
Urban.
So this is yes, sorry.
Urban area.
Urban area got the higher. Okay. Yes, very good. So from this, is actually test your logical thinking also lah. Okay. So you have to always look back at the title of the graph or the frequency polygon. What is this showing you? Okay, this is selling price. Just now is the swimming or the time taken for the swimmers. So you have to know, oh, this is a swimmer in the event of swimming, and this one is the selling prices. So you have to analyze lah. Okay. So for question C, I think it's very clear. Area A should be the rural, and area B should be the urban lah. Okay, because the higher selling price. Okay, so this is the answer. Okay, this is the exercise from textbook. We skip. Okay, so now go to the next thing I want to cover today. Okay, is how to construct an OR GIF. Okay, so I briefly read through the steps lah. Okay, so the first step is you have to add one class before the first class. Okay, just like the frequency polygon. But this one, OR GIF, you just need to add one class before. No need to add one class after. Okay, but for the frequency polygon, you have to add one class before and one class after. Okay, so there is a difference. So for first step, to construct an OR GIF, you need to add one class before the first class with 0 frequency. Okay, and then after you add one class, then the next step is find the upper boundary for each class. Okay, I repeat, find the upper boundary for each class and also the cumulative frequency. Okay, and also the cumulative frequency, which we already learned in the first class lah. Okay, then the next one, choose an appropriate scale. We will actually the question will give you the scale lah, so don't worry. Normally the question will give you the scale, so you just follow the scale only. Okay, and normally the x-axis will represented by the upper boundaries. Okay, whereas the y-axis will represented by the cumulative frequency. Okay, so this is the difference with histogram and the frequency polygon, because for the y-axis, histogram and frequency polygon use the frequency, whereas the OR GIF for y-axis, it use cumulative frequency. So you need to pay attention to here lah. Okay, And then for the horizontal axis is upper boundaries. Okay, next one, plot the cumulative frequency with corresponding to the upper boundary. And the last one, draw a smooth curve, okay, passing through all the points. And normally the shape of the ORGIF is like an S lah, okay, like an S like this. We look at the question, look at the example lah. Okay, so the next thing, if you're already done with your ORGIF, the next thing the question will ask you is, normally they will ask you to find the first quartile or the median or the third quartile. Okay, third quartile means it's actually this formula lah. Okay, here is the formula. Okay, whereas where n, what is represented by n? N is actually the number of data. Okay, number of data. Okay, number of data means how many data you are recording lah. Okay, normally the question will give you a table like this. Okay, with a lot of data here. Okay, so the total of this data, let's say there are 50 data, so means your n is 50 lah. Okay, your n is 50. And then how to find the first quartile is you take 1/4, multiply the total data, which is 50, and then you get the answer, which is 12.5. Okay, 12.5. So this is the first quartile. Okay, and then for the median you will use 1/2, okay, times the total data. So this is 25. And then for the third quartile is you use 3/4 times 50. And then you will get how many? 12.5 times 3. Okay, 37.5. So after you get this one, it's actually not yet, not done yet, because you need to refer to the ORGIF which you just constructed, and then you need to read. You need to read from the ORGIF to get the answer for your first quartile, your median, and so on and so forth. Okay, we will look at the example later lah. Okay, but for quartile, this is the formula lah. For quartile, how to find the first quartile, we use 1/4. Find the median, we use 1/2. And find the third quartile, we use 3/4. Okay, multiply with the total of data. Okay, so this is the quartile. Okay, so now let's look at the example. Okay, so given here is a frequency table of salt content of 60 types of food. Okay, so this is given here, the table. Okay, construct an ORGIF to represent the data. Okay, this is the first question. And then from your ORGIF, determine the first quartile, the median, and the third quartile. Okay, very straightforward question. So we look at the solution. So as I mentioned earlier, you have to find out the first class. Okay, I mean a class interval before the first class. This is the first class, but then you have to find out a class before the first class with the frequency 0, just like this. Okay, how to find it out? Okay, you can look at the pattern lah. Okay, look at the pattern. This is 149, 199, 249, and so on and so forth. So the difference is around 50 lah. So to get the previous one, actually you can just take 149 minus 50, you can get 99. And also for the lower limit, you notice that it's 100, 150, 200 also different by 50. So to get this one, you just 100 minus 50, you get 50. So you get the first, or you get the class interval before the first class with the frequency 0. Okay, this is the first step. Then you have to find out the upper boundary for each class. Okay, upper boundary. So I hope you know how to find the upper boundary. It's very easy. Just add the 0.5 at the end of the, at the lower, upper limit. Okay, put a 0.5 at the upper limit, you will get the upper boundary. Okay, so this is it, upper boundary. And then don't forget, you have to find out the cumulative frequency. Okay, cumulative frequency, very easy. Just copy back the first class frequency over here. This is the first one, 0. Then you add between 0 and 4. Okay, you get 4. And then this 4, you add the next one, frequency, become 15. 15, you add 15, you get 30. 30, you add 21, you get this one, and so on and so forth until you get 60. Okay? So this one, the last cumulative frequency should be the total data that you have. Okay? This one is referring the total data that you have. Because this 60 comes from you add 0 until 1. Okay? So actually you get the same answer here. If you add all this together, you get 60. So this one is actually your total data. Okay, so after you finish this table, you get everything already, and you can start construct your OGIF, where your x-axis is referring to your upper boundary. So this one, x-axis is referring to your upper boundary. So start from 99.5 until 399. So you notice that it's actually come from here. Okay, 99 until 399. Okay, it's actually come from here. And then the cumulative frequency, you use this one to plot on the y-axis. Okay, so we only use these 2 in 4 to construct our OGIF. Okay, so after you plot everything, okay, you will connect. Okay, you draw a smooth curve to connect all the points you just plotted. Okay, and normally the shape will be like a S something like this. Okay, so after you completed everything, then your OGIF is done. Okay, question A is done. And then back to the question B, asks you to find out the first quartile, the median, and also the third quartile. So we have to use the formula. Okay, for the first quartile, we use 1/4. Okay, times the total data. So total data is actually your highest point, which is 60. Okay, and then do the same thing for the median, but you use 1/2 times 60. And then for the third quartile is 3/4 times 60. So get this answer. Okay, get this answer, and it's already given here. Okay, 30, 45, 15. So this is the first quartile, this is the median, and this is the third quartile. So after you get this 15, 30, 45, your answer is not complete yet. So how to find out the first, median, and third quartile is you need to go back to your OGIF. Okay, let's say we do the first quartile first. The first quartile is 15, right? So go to your OGIF, and then at your y-axis, okay, find out where is your 15. Okay, so this is 10, 20, so 15 is at the center, at the middle. Okay, so after you notice this is 15, okay, use your ruler, draw a straight line, okay, across here. Okay, draw a straight line until you meet your OGIF. Okay, here, and then go down to your x-axis and read the reading here. What is the value here? And this value is your first quartile. Okay, this answer is your first quartile. Okay, this is how you find out the first quartile. After you use the formula to calculate the value for 15, okay, 15 here, you have to refer to the y-axis and then draw a straight line, okay, horizontal across this one, and then until you meet the OGIF, and then go down. Okay, so when you go down to the x-axis, this value is your first quartile. So the same thing goes to median and also third quartile. Okay, for median is 30. So if 30 means you have to find out where is your 30 on your y-axis. Okay, here, and then draw a straight line, horizontal line. Okay, go to your OGIF and then go down. Go down and read this value, and this value is your median. Okay, this one is your median. And finally, also do the same thing for the third quartile, 45. So go here, 45, go horizontal, and then go down. Okay, so how to find this value, 284.5? Actually, if you notice the first quartile and the median, it landed exactly on this upper boundary. So you can directly read from the upper boundary. But this one, okay, it landed not exactly on the upper boundary. So I think it's on the seven box after 249. So how to find this one? Okay, it's very easy lah. So you take this 249 and 299, right? This one 249 and then 299. Okay, 0.5 0.5. Here is 0.5. So you notice that between 249 and 299 there are 10 boxes. Okay, 10 kotak kecil. So find the difference. What is the difference between 299 and 249? Okay, it's about 50 lah, 50. So I take 50 divided by 10. Okay, why divided by 10? Because between here and here got 10 boxes. So I want to find out one box referring to how much. So when I divide, I get 5. So means each box referring to 5 mg. 5 mg lah, ikut unit ini . So one box is referring to 5 mg. So this one is around the 7 box. So if 7 box means this one, if I times 7, I got 35, right? So 35. So the value here, okay, the value here for this one, it should be 249.5 plus 35. Okay, so you'll get your answer 284.5. Okay. Or maybe many of you already know how to find it, but just in case, okay, some of you don't know how to find it, then this is how you find it lah. Okay, because you cannot get this wrong because if you're wrong, you totally lost the mark. Okay, although it's maybe only 1 mark for each question here, but it's very tedious lah. You need to find exactly the value. Okay, maybe there's a plus or minus 1 difference only. Maybe you can give your answer 285.5 or 283.5. So the answer between this range can be accepted. But if you give 286 or 287 is out of range, then you get the answer wrong. Okay, so this one you have to find it exactly the same or plus minus 1 lah. Okay, normally. Okay, so I think that is about how to construct ORGIF and how to find the quartile. Okay, there's only 3 types of quartile. It's either first, median, or the third quartile. Okay, so this is the answer lah just now. Okay. All right, this is the formula. This is the formula. And then this is the graph comparing the in terms of a line and in terms of a bar lah. Okay, it's two actually, both actually is the ORGIF, but this one is in terms of bar, and this one is in terms of a line. But normally we construct in terms of line. We don't need to draw the bar. We just draw the line. Okay, and this last part. Okay, this is the last part for today's lesson. Okay, it's about percentile. Okay, so what is percentile? Okay, we can analyze the large data more easily and effectively when we divide the data into small parts, known as percentile. Okay, and a percentile is a value that divides a set of data into 100 equal parts and represented by P1, P2, P99. Okay, this is just how if I want you to find the percentile of 37. So you represent the P 37. You write P37. Okay, this is just to represent which percentile you want to find. Okay, from P1 to P99. Okay, so let's look at one question example. Okay, the ORGIF on the right shows the score of an aptitude test. Okay, aptitude test obtained from candidates who are applying for a post in a company. So based on the ORGIF, find the 10th percentile or P10. Find the 46th percentile or P47. 46. So this is how we write the percentile. Okay, just referring to the which percentile you want. If P10 means the 10th percentile, if P46 means the 46 percentile lah. Okay, and then only those candidates who obtain 92nd percentile and above will be called for an interview. What is the minimum score required in order to be called for an interview? And the C question, what is the percentage of the candidates who obtain a score of 57 and below? Okay, so we start off with the first question, A. So find out the 10 percentile. So what is the formula for finding the percentile? Okay, it's actually like this. So if I want to find out the 10 percentile, what you do is you just take the 10. Okay, this is referring to the P lah. Okay, if you want to find P10, that means here you put 10 lah. If you want to find P46, means up here you put 46. Okay, and always over 100. And this one is your total data. Okay, because we look at here, the last one, this one should be the total data, and this one is equals to 50 lah. So the total data is 50. Okay, total data. So this is the formula lah. Okay, take the P over 100 times total data. So what you get is you get 5. Okay, so you get 5 for this one. So from the ORGIF, okay, from the ORGIF, so P10. So what you do is you have to find where is your 5. Okay, 5 is actually here. Okay, here is your 5. So after you find out your 5, just like how you find the first quartile and the median and the third quartile, draw a straight line to your ORGIF and then go down to your x-axis to read this point. So what is the value for this point? It's actually 46.5. So means the 10 percentile answer is 46.5. Okay, so just read from your ORGIF lah. So another word is you have to make sure your ORGIF is drawn correctly. Okay, if your ORGIF is wrong, then all of this percentile or quartile will be wrong because your graph already constructed wrongly. Okay, so you have to make sure that your ORGIF is very smooth. Okay, because once your ORGIF you don't draw in a smooth manner, if you run here and there, then the value will be slightly different. Okay, your answer will be slightly different. And if your ORGIF is langsung lari sudah, of course this value will be totally wrong. Okay, and then for the 46 percentile is also to do the same thing. Okay, 46 over 100 times 50, you get 23. So go to your graph. Okay, identify where is your 23. It's actually here. This is your 23. And then go to your ORGIF and go down to your x-axis to read the value. So 63.5 is your 10 percentile. So this is the answer lah. Okay, so this is the answer for A. Okay, so next is a question for B. Only those candidates who obtain for a 92nd percentile and above will be called for an interview. So 92nd percentile. So we need to find out what is the value for 92nd percentile first. So what you do is, just as the question A, find the 92 or 92nd percentile. Okay, over 100 times 50, you get 46. So from your graph, where is your 46? So identify your point here, 46. So go to your ORGIF and then go down. You notice that the value for this point is 77. So meaning, okay, for those candidates who obtain 92nd percentile, they will get at least 77 marks. Okay, 77 marks. And don't forget the question said and above, 92nd percentile and above. Okay, will be called for an interview. So since 92nd percentile is 46, which is 77 marks, okay, 77 score or marks, okay. So and above means this part or this total person from here, from this part, will be called for interview, okay. and all from here to here, the person from here to here who get these points will not be called for an interview. So the answer is, okay, therefore, only candidates with minimum score of 77 will be called for an interview. Meaning 77 marks and above will be called for interview. Okay? Because this point, until this point is 77 marks. So 77 marks and above. Okay? People from here to here will be called for interview. Okay? All right. So that is question B. And question C. Okay, let's look at the question. What's the question? What is the percentage of candidates who obtain a score of 57 and below? Okay, 57 and below. Okay, so this is the score. So x-axis is your score. So you need to find out where is 57. Okay, so from here 50, here is 60. So means 57 is between this range lah. And if you notice this between 50 and 60, there's 10 boxes also. And then the difference between 60 and 50 is also 10. So means one box referring to one mark or one score lah. So if 57 means is the 7 boxes. Okay, from here you count lah. Count 1, 2, 3, 4, 5, 6, 7. Okay, around here lah. Okay, I cannot exactly count it because it's too small. Okay, maybe it's around here. So this part is your 57. Okay, 57.5. Okay, so this one is your 57. So what you do is, now we do the terbalik opposite. Okay, just now when we find the quartile and when we find the percentile, we go from here, y-axis, come here, and then go down, right? So now we go terbalik. From x-axis, 57 score, we go up. Okay, we go up until you meet the OGIF, and then draw a straight line. Okay, go to your y-axis and read the value here for this point. Okay, read the value for this point. So the value for this point is your answer lah. Okay, so let's look at the solution given. Okay, so from the OGIF, okay, so just now we look at the 57. Okay, so this is the one. Okay, this is the 57. So when we go up and go to the y-axis, we found out that this one is 15. So means 15 students, okay, 15 students get 57 score and below. Okay. So the question is how many percent of students get 57 score and below? So when we already found out that 15% get 57 score and below, so how to find the percentage? So take 15 over the total number of students, which is 50 times 100%. So just as given here. So you get your answer 30%. Okay. So I want to notice, I want to highlight one thing is that if you want, once you read from here 57, let's say this is 57, okay, 57. Once you read from this one 57, go up and then go to your y-axis. This 15 is referring this part of your graph. Okay, so means 15 people will get score between 30 to 57 because we are using the cumulative frequency here. Cumulative frequency means you add from the zero, starting from zero until you get this point. So is so this graph, this part of graph is actually considered people who score between 30 to 57 until the point you read this one. Okay, this is the total number of students who get this score lah. Okay, so this because we are using the cumulative frequency. Okay, not 15 people got 57 marks only, but 15 people got marks between 30 to 57. So you need to differentiate this one. Okay, all right, so that is the thing I want to highlight. Okay, so I think I finished my lesson until here. I just want to cover these 3 things. Okay. So if there's any question you want to ask from you, any question about today's lesson, how to construct OGIF, how to find out the quartile percentile, also how to analyze the distribution for a histogram or a frequency polygon. Do you have any question? I hope you get it. Any question? I give you 5 seconds. 1, 2, 3.
No, sir.
No what? Okay.